Hello everyone, welcome to our lesson on divisibility of numbers. This is an activity for you. You have 20 marbles and 4 friends. If you divide equally, how many marbles will each of you get? Next, while you are playing, 2 of the marbles break. Now if you divide the 18 remaining marbles equally, how many marbles will each of you get now? Finally, one of your friends has to go back home. So now you are having 18 marbles and 3 friends. If you divide 18 marbles equally, how many marbles will each of you get now? You can think for a moment and write down your answers. So what was your answer? When you divide 20 marbles between 4 friends, each one will get 5 marbles. Next, when you are trying to divide 18 marbles between 4 friends, I cannot divide it equally among 4 friends. And then finally, when one of the friends leave, then I have got 18 marbles to be divided between 3 friends. So each friend will get 6 marbles. How did we find these answers? We did it by division. Now let us take a look at the different components of division. You have the dividend, which is divided by the divisor. The answer that you get is the quotient. And finally, if anything is left behind, that is the remainder. Let's take a look at this with the example that we had. So we were dividing 20 marbles among 4 friends. So the divisor is 4, the dividend is 20, we get a quotient of 5 and a remainder of 0. So we can divide 20 marbles between 4 friends equally. Each friend will get 5 marbles and the remainder is 0. After that, we tried to divide 18 marbles equally among 4 friends. So the dividend is 18, the divisor is 4, and we are getting a quotient of 4. But we are also getting a remainder of 2. And in the last problem, we are dividing 18 marbles between 3 friends. We get a quotient of 6 and a remainder of 0. And we said that we can divide it equally so that each friend gets 6 marbles. So what do we see here? In the first one, we get a remainder of 0. In the second one, a remainder of 2. And in the third one, a remainder of 0. So when we are getting a remainder of 0, that is when we can divide a number equally between the different friends. But when we are getting a remainder, that is when we are saying that we cannot divide that number. This is what divisibility is. So the divisibility tells us when a number can be divided by another number without leaving a remainder. So if a number is divisible, then the remainder will be 0 after division. So 20 is divisible by 4 because when we divided 20 by 4, we got a remainder of 0. 18 is not divisible by 4. When we divided 18 by 4, we got a remainder of 2. And 18 is divisible by 3. When we divided 18 by 3, we got a remainder of 0. So this is our objective today. We will be able to understand divisibility and find the rules of divisibility using patterns. Why are we doing this? Because divisibility is needed everywhere in our daily calculations. For example, when we are playing, studying, shopping, anywhere, we can always use divisibility to make our life easier. And if we know the rules of divisibility, we can always find out if a large number can be equally divided without doing the actual division. We will practice more of this in this lesson. So what are we looking at in this lesson? We are looking at the divisibility rules for 2 and 3. Let us start. How are we going to do this? We will look for patterns. We have already done number patterns in one of our previous lessons. So let us start by the divisibility by 2. I have 20 marbles. I have to divide it equally between 2 people. So each person will get 10 marbles. Next, I will take away 1 marble, which leaves 19 marbles. I will then try to divide it equally between 2 people. Can I do it? I cannot divide it equally because I get a remainder when I divide 19 by 2. The remainder is 1. After that, I take away 1 more marble, which makes it 18. Now, I will try to divide it equally between 2 people again. And I can do that. Each person gets 9 marbles. And so on. I keep on removing marbles and try to divide it between 2 people. I then list down in a table where I can divide the marbles equally and where I cannot divide. So this is what the table looks like. You can see the numbers 20, 18, 16, 14, 12. They are appearing under the can divide. And the numbers 19, 17, 15, 13, 11, they are appearing under cannot divide. So do you see a pattern here? Yes, it is the times table of 2 because 2 ones are 2, 2 times 2 is 4, 2 times 3 is 6, 2 fours are 8, 2 fives are 10, 2 sixes are 12, 7s are 14, 8, 16, 9, 18 and 2 tens are 20. So that is a 2's table definitely. But is there any other pattern you can see? Did you notice that the last digit is always 0? Or the last digit is in the 2's table as 2, 4, 6 or 8. Let us look at the number chart to see which numbers are divisible by 2. We will just cross out the numbers which are divisible by 2. What do you see? Every alternate number is divisible by 2. So every second number is divisible by 2. So this is what I found is the divisibility rule of 2. I think the number is divisible by 2 when the last digit is 0 and the last digit is in the 2's table. Also, they are all alternate numbers on the number chart once we start from 2. So once I have found the divisibility rule, I will test it on some large numbers. First, I list down all the numbers which either end with 0 or where the last digit is in the 2's table. So I have listed down 3 large numbers. Next, I divide them by 2 and I find out that the remainder is always 0. After that, I list down some numbers which do not have the last digit as 0 or a multiple of 2. And I try to divide them by 2 and every time I do it, I get a remainder of 1. So I found the pattern correctly. So what is the pattern? If a number is divisible by 2, the last digit must be 0 or it must be 2, 4, 6 or 8. So what were the steps I took to find out if a number was divisible by 2? First, I took very small numbers from 1 to 20 and checked if I can divide by 2 without remainder. I then listed down the numbers as the numbers I could divide by 2 and the numbers I could not. Then I looked for a pattern. I looked for a pattern in the numbers I could divide by 2 and I found a pattern. Once I found a pattern, I then tested by testing it on large numbers. I picked up 3 numbers which I think should be divisible by 2 and I picked up 3 numbers which I think they should not be divisible by 2. And I found out that whatever pattern that I had thought is correct. So this is how I found the divisibility of the number 2. Next, you will find out the divisibility of the number 3. How will you do it? Again, you will take small numbers from 1 to 20 and find out which are divisible by 3 and which are not. You will list down in this table the numbers which are divisible by 3, that is, they do not have a remainder, and the numbers which are not divisible by 3, that is, there will be a remainder. Then you will look for a pattern. You can do this in the next 5 minutes. We will also look at the number chart when we are doing the divisibility rule of 3. So, I think all of you have found out the different numbers which are divisible by 3. Let us look at our tables. On the left, you can see the numbers between 1 to 20 which I can divide by 3, and on the right, you can see the numbers which I cannot divide. So, 18, 15, 12, 9, 6 and 3 are the numbers I can divide by 3 without leaving a remainder. But 20, 19, 17, 16, 14, 13 and so on. These numbers, when I divide by 3, there is always a remainder. So do I see a pattern in the numbers which I can divide? Can you take a look and see? Yes, it does look like the times table of 3. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. But what else? Do you see anything else? What if I add the digits? Can you try adding the digits? 1 plus 8 is 9. 1 plus 5 is 6. 1 plus 2 is 3. What does that look like? They are all in the 3 times table. So it is the sum of the digits which is divisible by 3, which makes it divisible by 3 itself. Now let us take a look at the number chart. So let us cross out the numbers which are divisible by 3. What do you see? All the third numbers are divisible by 3. We had found out that all the second numbers are divisible by 2. Now we are finding out that all the third numbers are divisible by 3. So what is the divisibility rule of 3? So what I found out is the number is divisible by 3 when the sum of all digits is divisible by 3 itself. And they are also separated by 3 on the number chart. I now test this on some large numbers. So, I picked up some numbers where the sum of the digits is divisible by 3. For example, 669, when I add up the digits, it becomes 15. Then 1 plus 5, I again do it and I found out that the sum is 6. And 6 is divisible by 3. So like this, I pick up 3 numbers and I add up the digits to see what is their sum, and then I divide the sum by 3 to find out if they are divisible by 3. Next, I also pick up some numbers which do not have the sum as a divisible by 3. And I always get a remainder when I divide them by 3. So this is how I test my finding, and I find my pattern to be correct. So what is the divisibility rule of 2 and 3? The divisibility rule of 2 is the last digit is divisible by 2 or the last digit is 0. And what is the divisibility rule of 3? The divisibility rule of 3 is the sum of all digits in that number is divisible by 3. If the number that we get after adding all the digits is more than one digit, then we will add it again and we will find out if it is divisible by 3. You can look at this slide a little bit longer to understand the divisibility rules of 2 and 3. Finally, this is something for you to do again. Can you find the divisibility rules of 5, 6 and 10? You will start looking from the numbers 1 to 50. You can also use the number chart. And after you have found the rule or the pattern, you will have to test it on some large numbers to see if the rules that you found are correct or not.